Okay. We live? Get everyone hearing me? All right, welcome to Business Continuity Session 5065. This is VMware vSphere fault tolerance for multiprocessor virtual machines, a technical preview. My name is Jim Chow. Co-presenting with me is Wei Shu. We are engineers at VMware. We write software, in particular the software and technology that we'll be talking about today. Now, I should mention, importantly, that this is a technical preview, and along with that comes a number of very important disclaimers of a legal, financial nature. I won't get into any of these in too much detail. I will point out that because this is a technical preview, pricing and packaging for any new technologies or features discussed or presented have not been determined. In particular, what this means is I am not going to make any announcements in this presentations about releases or anything of that nature. So if you were coming here expecting me to say multiprocessor fault tolerance now in vSphere 5.5, not going to happen. I will say, though, that we are happy to have discussions about the technology, including timelines and perhaps, you know, getting technology in front of users such as yourself under the protection of a sort of legal framework, non-disclosure agreement, an NDA. A number of our customers are already under NDA with VMware, and so if you would like to have a discussion about this technology, everything you'd like to know, everything you could possibly come up with to ask, we'd love to have those discussions, again, under NDA, so you can, after the talk, if you'd like, you could contact us, give us your contact information, and whether you'd be interested in having a discussion under NDA. I should say that if you already have a contact within VMware, you know, you can talk to your nearest VMware sales representative, whoever you're in contact with, and they can also get in contact with us. So, numerous avenues for us to have further discussions, but this session, all about the technology. We have a lot of cool demos that we'd like to show you, and we're going to talk a bit about sort of the developments that we have in this technology. Okay, so that's the preface. This talk is about virtual machine fault tolerance, sometimes abbreviated VMFT. One of the first questions you might ask about that technology is what is it? And some of you might be familiar with it. You might have used it in vSphere before. Others, perhaps not so much. Rather than try to describe it in words, I thought it would be good to maybe just show you a demo of this technology in action. As they say, a picture is worth 1,000 words. And I couldn't agree more. In this case, we have a remote desktop session. This is a live stream from our labs at VMware. I have here the vSphere web client. Okay, it's running a VM here. It's a Ubuntu Linux 64-bit VM. It's got 2 vCPUs, 2 gigs of RAM, a hard drive, Ethernet adapter, all the rest. Okay, so relatively normal virtual machine here. I happen to be SSH'd into that virtual machine, so I can do something like that. This is one of the benefits of streaming across continents. There we go. Okay, well, hopefully it's not going to do that the entire time. So I can. So this is a normal VM. I'm SSH'd into it. I can. It's got 2 gigs of memory, as I was saying. Can run the uptime. It's been running for 10 days, pretty long time. And let's see, I'm going to run top. Going to change the update interval. 1 second. You can see it's running processes, doing what it normally does. I can pop over here and we can see that we actually have 2 vCPUs here. Anyway, it's a normal VM. I'm SSH'd into it. It's running in a data center. Now, if I go back to the vSphere web client, this host, this VM happens to be running on an ESX host. That host happens to be w1-vmg ft082. Blah 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 blah. I happen to be SSH'd into that ESX host. I can run a command here, vmdumper-l. That'll tell me what VMs are running. I can see I'm running Ubuntu SSH, all perfectly as expected. Now, let's say you're using the system, somebody comes along, storking around the system, they do something like this. Normally what would happen when you reboot a system forcefully, it'll bring down your ESX host. All the VMs that are running on that host will be forcefully terminated. Usually carnage then ensues. Your users and so forth get quite distressed and come knocking on your door. Usually not a good idea, not something you want to do. I'm going to go ahead and do that. And what happens, server unexpectedly closed network connection. That's the connection to the ESX host. That's PuTTY giving us that error. Completely normal, completely expected. A perfectly reasonable reaction to rebooting that host. It's gone now. What you will notice, though, is that the VM that was running, still running. In fact, it hasn't missed a beat. It's continuing to execute the process I had started earlier. And in fact, I can continue interacting with it. I'll go back here, I'll quit, run the uptime again, 10 days. And I could do all the normal things you would do with a VM, just like as if nothing happened. But in fact, the machine that I was running on was obliterated. So that's the technology in a nutshell. I'm going to switch over to the slides here, and what I'd like to do now is sort of kind of put what we just saw in a little bit of context and describe why this is sort of really good for you. And what we just saw, one of the things you will notice is that there was no downtime of the application. You had continuous availability, continuous connectivity to your application, even though the hardware that was running the application failed, that the server went down. And I can tell you from experience that's not normally what happens. Normally what happens when the server goes down, everything goes down with it, including all your workloads, and people will notice that the connectivity to those applications will cease to exist. But with virtual machine fault tolerance, doesn't happen. Kind of like magic, and in many ways it sort of is. It appears as sort of this magical capability, but I can tell you that VMware or VM fault tolerance is no different from any other fault-tolerant technology that has ever existed. Really, all fault-tolerant technology boils down to the same basic trick. And that trick is very straightforward. Basically, the only idea here is that you have multiple replicas of some state that you want to protect. And at any given point in time, you present to your customers, your clients, your users, a view of one of those replicas. And if one of those replicas becomes unavailable, then you sort of seamlessly transition to a view of some other replica, hiding the fact that there are failures and so forth to the users. So that's the trick that all fault tolerance technologies play. Virtual machine fault tolerance is no different. We play the same game and do the same trick. Now I will say though that that basic idea is very hard for applications to do. It's actually a very tricky game to play. And the reason for that is it's actually quite complex to sort of structure your application to sort of organize its data into various nodes, to manage the communication of those nodes. What happens if the communication fails? There might be disjoint sets of nodes that can communicate, handling atomicity and sort of the seamless transition between different replicas. It's all quite complex, and sort of the atomicity and so forth. It's such a complex problem that a lot of applications, actually very few applications, even attempt to solve it. Usually only ones where fault tolerance is particularly important, a database, for example. Even if an application tries to sort of solve the problem, whatever they come up with usually ends up being fairly complex, not just for the developer of the application, because they have to deal with all these very complex hairy problems, but also for the users of the application, because now they're sort of laden with the responsibility to sort of manage and configure this sort of complex system. What we've done here with VMFT is we've sort of boiled down all the complexity that exists in several different disjoint applications and sort of centralized it all in the hypervisor. We've taken all that complexity and put it in the hypervisor. And so by doing this, we sort of freed the applications from actually having to care about fault tolerance. In fact, guest software that's being protected by fault tolerance actually has no way of knowing that it's even being protected by fault tolerance, and cannot even tell, even if it wanted to, when failovers occur, when failures are happening, nodes are being brought down, and that the workload is being transitioned to other hosts. All of that's completely transparent to the software running inside the guest. And because of that, because we've boiled down all that complexity and put it in the hypervisor, we've actually saved complexity from two perspectives. One, from the application's perspective, applications no longer have to write fault-tolerant code. You might, as a user, you might already have software that you want to run that does not have fault tolerance built into it, and it doesn't need to. On the other hand, even if you do have fault-tolerant software that you already run, by taking that complexity and putting it in the hypervisor, we've actually eliminated a lot of the responsibility that comes with running a fault-tolerant system, because it's all being handled in one centralized package. So, if you had a database that had fault tolerance, you don't have to be an expert database administrator to try to configure and enable fault tolerance. Have to deal with redo logs and all these kinds of nasty issues when it comes to administering a large distributed system. By boiling down all this complexity down to the hypervisor, we sort of take care of all that problems for you. So we've solved the problem so applications don't have to. And a consequence of that is that VM fault tolerance can protect basically any workload that you want to run in vSphere. You can take any guest, Linux, Windows, any application, be it database or SSH or any custom Java legacy application that you can come up with that you're already running. All of it can be protected with fault tolerance. And once enabled, your applications just keep running, even when hardware fails. And that means TCP connections to those applications remain connected. Clients never experience any downtime when servers fail. Okay, so that's basically a summary of the technology, why you would want to use it, why it's really good for you. Now, another thing I should point out is that sort of fault tolerance implemented in the hypervisor is actually really easy to use. It simplifies life for, as I said, two folks. One, people who are running one applications, they no longer have to care about fault tolerance, and the users of those applications are no longer laden with responsibility to have to manage a fault-tolerant cluster and try to configure a bunch of information they don't really care about, because all of that's being handled by a hypervisor. So it's a very easy operation to use fault tolerance, and to demonstrate that, I'd like to show you how we can do that on a real system. So I don't need this anymore. I'm going to close that window, close this window. Okay, so I have my vSphere web client connected to vSphere. I'm going to open up a VM that we've got here. It's going to search my cluster, find an appropriate VM. Okay, I've got one already loaded. It's called FT VM1. It's not very imaginatively named. Let's see what's going on here. Yeah, that's the one I want to run. I'll click on that. All right, so vSphere, vCenter, I should say, is loading up a summary of this VM. So we've got a normal VM here, very similar to the VM I showed you at the beginning of the talk. It's an Ubuntu Linux VM, happens to have 2 vCPUs, 2 gigs of RAM, hard drive, network, all the normal stuff. In particular, this VM is not fault tolerance protected. Let's say I want to do that. I want to enable FT. What do? I go over to the actions here, go to all vCenter actions, go to fault tolerance, which is here, and then I turn on fault tolerance. I say what this will do is it'll bring up a wizard. It'll sort of ask me various questions. Now, as I mentioned before, fault tolerance technologies, they work by creating replicas. In this particular case, when you enable FT, you're going to create a replica of the VM, what we call a secondary. The original VM we call the primary. So you're creating a secondary. This dialog is asking us where we want to place the secondary's disks. In the system that I'm showing you today, the primary and secondary, they have their own VMDKs. So it's just asking me where I want to put that. I'm going to go through and decide to put that here, relatively arbitrarily. Going to click through here, selected data store. Yeah, that one's fine. Okay, so click through here, selected data store. I go to the next pane. What it's going to ask me now is select a host to run the secondary. Again, this is, we have a cluster of machines. We're going to protect that virtual machine. We're going to have that secondary run on some other host in our cluster. Pretty arbitrary, doesn't really matter. I will say that this VM is currently running. It's running on host 85. So I can pick any other host in this cluster. I'll take 81. Sort of verifies that my selections are correct. Click Finish. We've got a task here on the right. Starting task, turn on fault tolerance, and that's it. You're done. After this, fault tolerance is enabled. You don't have to worry one bit about what happens next. There's no ongoing maintenance with virtual machine fault tolerance. This is basically a point-and-click operation. So this task is finished. It says fault tolerance is enabled. We're going to sort of refresh the status of the VM. I believe it's doing that right now. And see if we've got that information loaded. So we scroll down here. I gotta wait a sec. All right, there we go. We have a fault tolerance submenu. It says fault tolerance status, protected. Secondary location, 81. That's the host that I selected. So we have a VM. It's running on 85. It's being protected on 81. That's all there is to it. Now, if I wanted to, I could log into the ESX host running on 85, reboot it, force a failover over to 81. Not going to do that now. It's a pretty invasive maneuver because it brings down the ESX host. It becomes unavailable for all their VMs. However, if you do want to test a failover, we have a somewhat less perturbing way of doing that. So we go over to all vCenter actions. Fault tolerance, we'll click on test failover. Okay, so what this will do is it will bring down the primary that's running on 85. it will switch over the VM to be running on 81. As we see test failover completed. We'll wait for this to refresh. 81 will take over the job. It will continue running. Your users won't experience any downtime. They don't care whether it's running on 85 or 81. vSphere takes care of that. And let's see, what do we got? It's refreshing host 85, host 81. So now it's running on host 81. I'm going to scroll down to the bottom here, see what's going on. Fault tolerance. Okay. Very fast here, but what it said here is fault tolerance is protected. Now the secondary is 86, W1 VMG FT 086. So it was 85 and 81. We tested a failover. 81 was the secondary. Now it becomes the new primary. vSphere notices that we have a VM that is a primary. It has no secondary. So what happens is vSphere will automatically search your cluster, find an appropriate host to run your secondary, and it'll reprotect your VM automatically. In this case, it selected 86 to run it, and then just reprotects it. The administrator of vSphere didn't care about that at all. There's no ongoing maintenance. When failures happen, vSphere just takes care of reprotecting your VMs. It figures out what new host in your cluster to use as a secondary. At all points in time, your VM is always protected no matter what failures are happening inside your cluster. As long as you have 2 hosts in your cluster to run the protection on, vSphere will find that and protect it for you. Okay, so that's a very basic demo. I'll get my clicker in the back here. And I will switch back to the slides here. So what we saw there is VMFT is sort of doing a lot for you. It keeps the lights on for you. It sort of centralizes all the complexity that comes with managing fault tolerance. It's dead simple to use. You point the VM that you want to run. You can turn it on any running VM that you've got. You say enable FT, you enable it, and that's it. You sit back, you pat yourself on the back for a job well done. vSphere takes care of the rest, including, if there are failures, reprotecting your VMs. So that's sort of a simple, what we've seen so far is sort of very simple capabilities. We've protected, SSH VMs and Linux and so forth. I can tell you that that's not the only things that the technology can do. We could actually do a lot more interesting things. And for some of that, to sort of elaborate more on that, I'm going to introduce my partner here, Wei Xu, who's going to talk about how VMFT actually protects the stuff that you really care about.
Okay.
Wait.
Thanks, Jim. Hi. Hello, everyone. My name is Wei Xu. Jim gave us an introduction about what is VM fault tolerance and why it is good for us. One of the beauty of VM fault tolerance is that we implement all this complexity of the fault tolerance inside hypervisor, so that this technology can be used for almost all applications, and no matter what kind of operating system you are running, what kind of application you are having. So because the technology itself is transparent and agnostic to this upper layer guest level stuff, the OS and applications. So we have tried actually test this technology on a variety of workloads, and including things like database servers, like Oracle servers, and like Microsoft Exchange server, and many of them. So here, again to show that capability, use one of the workloads we have inside of VMware. I think many of them probably are very familiar with that. It's a vCenter server. So vCenter server is basically the server we use to manage a bunch of ESX, basically a cluster of ESX hosts. So it's a very, very complex workload. It is also a very, very central, central point of a ESX vSphere cluster. So without vCenter, you cannot do a vMotion. So the DRS also requires the presence of the vCenter. So maintaining the continuous availability for vCenter is really, really important. But also it's very, very critical very, very difficult job to do. And in particular, the application is so complicated, right? So if you want to retrofit the application with fault tolerance capability, that's a very challenging engineering work. Unfortunately, we have not actually reached that point yet. But the good thing is that we can use fault tolerance, VM fault tolerance technology to provide continuous availability for applications like a vCenter server. And in particular, vCenter server it requires a lot of CPUs because it needs to manage large clusters. So that requires multiple vCPUs for vCenter server. That also makes the technology we are showing here a very good fit. So here, let me switch back to the demo. So I'm going to look at a vCenter VM. I call it Finance vCenter. This is basically, assume this is a vCenter to manage the ESX cluster for a finance department. vCenter is already important. The vCenter server for a finance department, we can imagine, can also be very critical for the availability. All right. So I have already enabled fault tolerance protection on this VM. So currently, this VM is running on host 86, and it's a secondary VM running on a host called 83. Let's look at some information about this VM. So this VM has 4 vCPU and has 8 GB of RAM memory, has a bunch of hardware drives. Let's take a closer look at this hard drives of this particular VM. So this brings up the VM configurations, and we have here we showed already 2 hard drives. Actually, has another 6 more hard drives of this VM, and this hard drive, all of them actually are sync provisioning. So this is, I think, important thing I want to point out. This technology, we can the VMDK format, we can support all formats that are available today for VMware virtual machines, not just a sync provisioning hard drive. The point I want to show here is that this is a non-trivial workload, and this is a pretty reasonably configured VM, has a bunch of hard drives and 4 vCPUs and some amount of memory. Okay, it's running currently with FT protected, and we also can see this VM has IP address and ends with 68, and the one I'm currently connecting to is 25. This is this is vCenter that manages this finance vCenter VM. So I just want to make sure we are not confused here. For this finance vCenter VM, I also connected to it through the web client. So this is the second tab of the browser window. So this one, as we can see from here, is connecting to 68, which is the finance vCenter VM. So we can do the normal vCenter operations of that VM. For example, we can look up a virtual machine called VM2, and then the web client will talk to the backend vCenter, the finance vCenter VM, and bring out all the information about that particular VM, and then show it in the summary pane here. So basically, we have a vCenter VM that is fault tolerance protected by our technology, and is running here. So now, what I'm going to do is basically do a failover, a demonstration. So this VM, the vCenter VM, is running on the host 86, as we mentioned earlier. So I'm going to connect to that host and reboot the host, which normally you should not do in a data center, because that's going to break down the host and bring down all the VM running on that host. But sometimes disaster could happen either because of power outage or because of the misoperation, right? So when that thing happens, we certainly don't want the workload, in this case, the vCenter VM, to go down. So let's see whether we can get that protection through our Photons technology. Again, we are on the host that running the vCenter VM. We can say the VM is running here. Okay. Now, let me reboot the host. So the host is gone, as expected. But how about the vCenter VM? So let's go back to the tab window that we have the web client connect to this vCenter VM. Let's, look up another VM here. So we are still, we can see this, okay, we got the VM1 information. That means the vCenter VM still up and running and can answer the queries from the web client. So there's absolutely no downtime. So I think if you tried reboot the vCenter VM, especially after disaster shutdown or basically power outage of the VM, you will notice that recover from the VM will take very, very long time. If not, a half an hour or more, definitely more than 10 minutes. So it's because it's a lot of service running inside the VM, and a lot of database recovery need to be done. But here we can see there's absolutely no downtime, right? So we did the part, we just reboot the host, but the VM still up and running, still can answer the queries from the web client. We can also basically, for example, we can power off the VM as well. So everything should just work. So that basically shows the powerful needs of the VM for torrents technology. So even though the vCenter it's a very complex workload, and it's very hard to retrofit to make the for torrents, but with the VM for torrents technology, we can get for free, because all the technology comes from the hypervisor. We don't have to touch the application to get that protection. So this is one thing. Another thing I want to show here is the backup of Photons VMs. When we want to protect a virtual machine with Photons, that normally means that machine is pretty important. For such important workload, we definitely want to also make a backup of that. One major way to make a backup of the virtual machine is used through the API called vStorage API for data protection, or in short, VADP API. To use VADP API to make a backup of a virtual machine, your first step is you have to create a snapshot of the virtual machine, and then you can make a copy of the snapshot and onto some basically more secure storage, like maybe tape or offline disk and so on. And what I'm going to show you that with this new technology, we can also make a backup of these virtual machines by first taking a snapshot of that virtual machine. For this, let me go to a virtual machine, F3, FT-VM3. It's here. Again, this is a FT-VM. We have enabled FT on this VM before this session. And from From the vCenter menu, we can look at its own snapshot. There's a snapshot manager here. Currently, this VM does not have only snapshot, but for VADP backup, we need to create a snapshot for this VM. I'm going to show that. So there's no snapshot right now. And we can see this VM right now is running on 885. I have already written a script that can make a backup, can take a snapshot of this VM. So let's log into the host. So where I'm going to run a script. It's a way to simulate the VADP backup process. So this is a VADP script that will take the argument, which is a VM name. So I'm going to create a VADP compatible snapshot of this virtual machine. Okay. So now we have just created a snapshot. Let's take a look at this snapshot, whether we can see it from here. So let's open up the snapshot manager one more time. So this time, when we have the snapshot manager, we will see that the snapshot called VADP snapshot that is created for backup purpose. So with this snapshot, the VADP solutions, I mean that there are many solutions today are available on the market from our partners. You can use any of those solutions to make a backup of this VM, even though this VM has fault tolerance enabled. So after the backup, we can just delete the snapshot. Okay, so that's a demonstration that we can create a VADP compatible snapshot for the fault tolerance protected virtual machines, so that we can make a back copy of this VM in case that a disaster happens. All right. So I'm going to show a few more demos. The next one I'm going to show you. We have seen we enable the fault tolerance for 2 vCPUs and 4 vCPUs. It took us several years go from 1 vCPU to 2 vCPU, 4 vCPU. People may wonder what's the limitation here, right? So the point I want to make here is that fundamentally this technology it can scale up for more vCPUs. It's really just a matter of resource, hardware resource available. What I'm going to demonstrate right now is I have a 16-way vCPU VM, which I already enable FT with that, and it's running just fine. So this is a VM. It's again the Ubuntu Linux VM, and we can say it has 16 vCPUs. And again, it's FT protected with its own primary running on 885, and a secondary copy on 881. So we can log into this VM to make sure actually it has 16 vCPUs. I mean, it's not really necessary because I believe the VI class should not lie about that, but just want to double check. So I'm going to show all the VMs, all the vCPUs here that need a larger window here. So this is a VM. Right now it's FT protected, has 16 vCPU running, and it works just fine. So this is basically, I want to show that, I mean, the fault tolerant technology really can scale up. On the other hand, we can also scale out, basically allow multiple FT VMs running on a single host. So let me take a look at one of my hosts, for example, 885, maybe. So this one, actually, you can see from here, we already have 2 virtual machines, which is FT protected, running on this host. Let's move, basically pack another one here. So I think we still have the SSH VM. It's not running here. So this is a SSH VM, basically Jim used in the first demo, and he did a failover, and that VM still a FT VM. So what I'm going right now, the VM is running on 83. So I'm going to move this VM and put it onto 85. So add one more VM, FT protected VM on that host. So to do that, basically this is vMotion. Okay. This is, at the same time, basically, I'm also showing that fault-tolerance protected virtual machines, just like any other virtual machines, still maintain the virtual machine property in the sense that you can just like move it around within your data center. So it still contains the mobility, which is a kind of fundamental property of virtual machines these days. So this is just a normal vMotion wizard. I'm going to select 85 as the destination so that we can add one more fault-tolerance protected virtual machines on that host. And I just take the default for rest options here. Okay, we are done here. So that we can see that the relocate task is going on. With relocate, basically, we are vMotion the VM from one host to another. In this case, we are moving from 83 to 85, so that we have more VM running on the 85, more FT protected VM running on 85 hosts. Okay. So we can take a look at the virtual machines on this host. It should now show 3 FT protected VMs. Like here, the SSH VM, the new VM, we just moved over there. So running 3 right now. So the last demo I want to show is basically is the virtual machine, the fault-tolerance protected virtual machine has mobility. That applies not only to its own the primary copy, the primary virtual machine, but also applies to the secondary copy, so that even the secondary virtual machine, fault-tolerance protected VM, is no exception, still contains the mobility. For that, we have a special option, because normally you would not be able to say the secondary virtual machine of a FT protected VM. So you can go to the action and all actions and the fault-tolerance menu. There's one particular item called migrate secondary. That will allow you to migrate the secondary copy of fault-tolerance protected virtual machine. So again, I mean, we just select the default. We can pick the cluster for FT cluster and pick only of the machines. Let's see whether 81 works or not. So right now the secondary is running on 84. After the migration is finished, we can say the secondary has been migrated to the 81 as we expected. So that's the demo. In the demo, basically, we show that with VM fault-tolerant technology, we can protect the workload you care about, even though they are complex legacy workload. And we can also back up the virtual machines. You can scale up the fault-tolerant VMs and also scale out, and you still retain the mobility of virtual machines. Here, one thing I want to point out here is that we talk about VMware virtual machine fault tolerance. Many benefits we have mentioned here are already available today in our product if you only want to use a virtual machine with one single vCPU. So we already have a uniprocessor fault tolerance shipped since ESX vSphere 4.0, if I remember correctly. So you can use that if you don't need more than one vCPU. And I'm also going to mention a few differences. With some of them we mentioned during the talk, some of them we did not really get into during the talk. So for your reference here. So the first thing that the technology we show off here can support more than one vCPU. That's the most important difference between the current product we have in vSphere. Another important thing I think worth mentioning is that with today's product, we pretty much require the cluster for tolerance to be homogeneous in the sense that you have almost identical CPUs and also almost identical ESX versions. The requirement is very, very strict. But this technology we are showing off here, it's much relaxed. So it's really just come down to the EVC compatible and enhanced vMotion. So if you can do enhanced vMotion between two hosts, then you can use these two hosts as a pair to protect your virtual machine. Another thing is if people are, really looking into the technology of the current uniprocessor fault tolerance, you'll notice that hardware-assisted memory virtualization is not used for those virtual machines. So that's some limitation of that technology. But with this technology, we actually require that, and that will bring a lot more performance to the virtual machines. And during Jim's demo, to enable the fault tolerance on the VM, the FTVM1, that VM actually is the power-down VM. So that basically demonstrates that we can do how to enable our fault tolerance with this technology. With this technology, we also provide the redundancy for virtual VMDK files. So you not only have a separate copy of the virtual machine on another host for the memory and CPU and other device states, but also you get a separate copy of the virtual disks. So in case the data store that saves the primary VM is going down, you still have a different copy of the secondary copy of that virtual machine. And we also show that this new technology is compatible with VADP backup solutions. And one other thing we want to mention that because this technology can support multiple vCPU VMs, it has a higher resource requirement. It requires a 10 gig connection instead of just 1 gig connection as needed for the current shipped UP product. So with that, I'm concluding my talk. Basically, in summary, this talk presents new technology to enable fault tolerance for multiprocessor virtual machines that can give you protection against the hardware failures. You no longer need to worry about the hardware failures, so because your virtual machine will be protected by the secondary copy. And it's very simple to use. As you can see from the demo, it can come down to just point clicks, or if you prefer, you can use just virtual vSphere SDK to do the work. And that's all because the vSphere type provider taking care of all the hard work, all the nitty-gritty details, so that it frees the application and gets operating system from this fault tolerance duty, and it can provide the workload you really care and has a pretty good scalability as well. So that's it. Jim and I will be here for any questions you may have. Thank you.
Should mention there's a survey on the mobile app, and if you're after you've taken.
Another thing, if you want to have questions, I think we have 2 microphones.
Yeah.
Please
we can repeat the question for you. Well, yeah, I think you had your hand up first. Yeah. Yeah. Ah.
The question is obvious.
Already have to.
May I? The question is obvious. When it will be available? You showed something of that last year, and still no availability of at least 2 CPUs, please.
Yeah, as I said at the beginning of the talk, I'm not going to make any announcements. If you'd like to talk about schedules and so forth, we'd be happy to do so under the protection of an NDA. That would be a discussion we're more than happy to have. Let's go to the left.
Okay, another question is, if you have a virtual machine with 16 virtual CPUs and each virtual CPU has, for example, 8 cores, will the technology work? 8 virtual cores for each virtual CPU.
When we talk about virtual CPUs here, we actually we meant actually virtual cores, right? So
it's equivalent from our technology standpoint. So if you have 8 by 8, it's 64 vCPUs from the standpoint of the technology. There's no fundamental limitation on the number of vCPUs we can support. It's limited only by how fast your hardware is, how fast your network is, how fast your memory is, and so forth. So assuming you have the appropriate hardware, that you have 64 pCPUs to run those virtual CPUs, and you've got enough memory and all bandwidth galore, we should be able to support it. That said, we tend to not run those kinds of monster configurations.
So the answer is yes, as far as I see.
There's no fundamental limitation. We'll put it that way.
Fundamental hardware or fundamental marketing by VMware?
I'm not sure I understood that question exactly, but there's nothing stops us from running such a large VM.
I think technically, we are engineers here, okay? So technically speaking, we don't say any fundamental limitations to prevent us to support 16 vCPUs. It's a function of basically the resource you have on host, and also function of the workload and many factors. It largely drives down to performance, what kind of level you can accept.
Yeah.
Okay, thank you.
Yeah.
In view of the old, is it my turn or is it someone else's?
Yeah, go ahead.
Yeah. In view of the fact we've now got effectively redundant VMDK, does this mean that we can create fault-tolerant machines without shared storage?
Yeah.
Cool, good.
Yeah.
A nice simple question with a simple answer. Thank you.
Yes.
Yeah.
Have you tested it on top of the multi-site storage cluster?
But by the way, I do want to add one point to there. If you use non-shared storage for fault tolerance, you may have a problem if one of the hosts goes down, so that you may not be able to automatically re-enable FT. Right. So you have to be aware of that.
So to repeat, have you tested it on top of your metro storage cluster technology, so that if you have your cluster stretched across multiple sites with replicated storage, have you tested this fault tolerance on top of that, so you can lose a whole site and a whole storage array and have it come up on the other side?
Yeah, that's a very good point, but we have not, run the test on the metro cluster yet, but certainly it's an area we really want to look into that as next steps.
We have someone raising their hand over here and over there.
Are there any memory limitations to the VMs that can do fault tolerance?
Memory, you mean the
amount of VRAM?
RAM, yeah.
Again, no fundamental limitation. Any amount of VRAM is all the same from the technology's point of view.
Thank you.
Actually, memory is a lesser problem. This is why I did not bother to show the demo for memory.
Yeah.
Do your software checks on the state transfer between primary and secondary?
Can you repeat the question?
Do you checksum the state transfer between the primary and the secondary?
We checksum the state transfer. We could. There's already some amount of checksumming that's going on for you. There's TCP checksums. There's other kinds of checksums that are going on in the system naturally. I don't think we do anything special more than, let's say, vMotion would do. So it's basically equivalent to that in terms of sort of quality of the replica. You have a good question over there.
Have you tried this with operating system clustering technology? Can you have both nodes of, say, in a Microsoft SQL cluster protected by fault tolerance. So you're sort of doubling your protections, software protection at the OS and application level, and the hardware protection with FT.
We had, I don't,
first of all, we definitely basically experiment with Microsoft SQL Server so that make sure our technology works with, can protect Microsoft SQL Server. Regarding whether we can use both the Microsoft, I think you probably refer to something like a Microsoft cluster solution.
Yeah, Microsoft cluster services or something like similar.
So, I mean, you could use that both, but in our reading, we look like, at least from what we have heard from our customers, many customers, they think it's very difficult to configure MSCS, and they would love to get rid of that by using the fault tolerance plus some other technology we have in VMware.
I'm not disagreeing with you on that front, but there are plenty of customers who want to protect at the application level as well.
Yeah, that's definitely a valid thing. In fact, you know, one thing about the fault tolerance technology we described is, you know, is probably obvious, is that it doesn't go higher than the hardware and the ESX platform. So if there are ESX problems, you know, you get the ESX crashes, we can protect against that. If the hardware fails, you can protect against that. Application level failures, you need some other solution. It's perfectly valid and reasonable to
and the new version's going to be perfectly happy with that.
Yes, 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 yeah. I should say also there are VMware, you know, application level HA type things that could also be used as well. We have a question over there.
Hi, what's the approximate overhead on CPU and networking in particular, given the large number of CPUs you need to keep in lockstep?
Yeah, so the overhead is a good question. I would say that, it's really a function of workloads. We definitely run a lot of benchmarks in the lab. I actually think I might have a slide on some of the benchmarks we've run. Yeah, probably towards the end here. Do I? I guess I don't.
Did you go to the end of that?
Yeah, I went to the end. There it is. There it is. Yeah. Okay, let's put that up there. Okay, so we've run a few benchmarks. You know, we've run SQL Server, 2 and 4 vCPU. We run Oracle databases with a swing bench, sort of a standardized benchmark. 2 and 4 vCPU as well. Here are some of the performance numbers we get. You know, it varies depending on the workload. Some of them we're getting sort of high, you know, almost 80%. And that's a ratio of the fault-tolerant VM over the sort of non-fault tolerant, you know, VM running the same workload. And so we get, you know, close to 80% for some, you know, with the Oracle 4 vCPU, it's under 60%. So, you know, still got some work to do, but it basically runs, you know, it depends on your workload. It runs in a range here, over 50%, you know, under 80% for these workloads. We definitely have workloads that have single-digit overheads, so that it runs almost exactly what, you know, native non-FT would run. And certainly we have workloads that perform much, much worse than this. It's all a function of what your particular application is doing. Most of this on the you know, database side, you know, you had a question about network impact. I will say that the technology we have presented today doesn't really have an impact on network bandwidth per se, but latency is something that will increase with the technology. So if you have a latency sensitive application, that can be a challenge. But bandwidth, as these sort of benchmarks describe, can easily be handled. We have other questions? Raise your hand if you have a question. I see no other questions.
Okay.
If so, thank you for listening.
Thank you.